Okay, well, hopefully it is for the sound. Oh, sure. Will serve. Okay, we have a system to solve by elimination. System is 3x minus 5y equals 2. 5x plus 2y equals -7. Now, if you do these the way you see me doing them here, and I do recommend it, although I don't require it. But if you do, that's going to be a little bit your bad. Okay. I call this equation 1, I call this equation 2, and I write down what I do with each equation. Okay, everybody chose to multiply the first equation by 5 and the second equation by -3, which would give me 15x here and -15x here. Could as easily have multiplied the first equation by 2 and the second equation by 5 and eliminated y. It's either one way or the other. So it's natural to just kind of choose the first variable. But sometimes the numbers match up better with y than they do with x. Okay, so whichever way they match up most nicely, this is the way you want to do it. Now, what we're going to do, I'm going to exactly what you want to do. I'm going to do 5 times the first equation, which means 5 times whichever equation was first in the last step. Okay, and that's going to give me, as you know, 15x minus 25y equals 10. Second equation, I'm going to multiply by -3. And I'm going to get -15x minus 6y equals 21. Now, when I add the equations, the x's go away. I get 0 minus 31y equals 31. 31 here, 31 here. I don't need to write the 0. Now, a couple of things before I solve this. Notice that I'm aligning my equal signs here so everything just stays nice and aligned. Okay? Keep everything lined up as long as possible. So then we proceed to solve this. Okay. We're dividing -31 by -31 and up by equals 1. And that's very convenient. Now, if you made a mistake in here, then you would punish yourself by probably having a fraction here and having to deal with it. But when I put things on a test, I'm not going to necessarily avoid fractions. Okay. Once you want to see deal with the fractions. Then, as I've done past, take this solution, draw up to one of these functions, often the first one could have been the second. Then I'm going to plug the 1 in for y. So out of that, again, I'm getting the equation 3x minus 5 times y equals 2. And I'm not going to write y, I'm going to write y equals 1. So that gives me 3x minus 5 equals 2. So that 3x equals 7. Now there's an intermediate step. You want to include the intermediate step. Now skipping the step. Again, you want to include the intermediate step to keep reinforcing it because people at this stage are typically still a little bit shaky with the rules that you apply to solve an equation. You want to repeat them every chance you get. It just doesn't take long. And then x would be 7/3. Somehow that doesn't seem to work. And the reason it doesn't work is that y isn't one. Okay. Y is negative one. I divided by negative 31 here. I neglected to write the negative on this. Okay. Now, how did I figure out that that didn't work? Well, I plugged x equals 7/3 into the first equation. 3 times 7/3 is 7. 5 times 1 would be -5. 7 minus 5 does equal 2. Well, since I used the first equation to get this value, there's no surprise that this satisfies this, but it doesn't satisfy this equation. 5 times 7/3 gives me 35/3. 2 times 1 gives me 2. And neither one of these is negative, so I'm sure I'm not going to get a -7 out of it. So I can see right away that this didn't work. Okay, so now we correct it. That's why we always check. Never solve a problem without checking unless you're so much of a hurry you just can't possibly do. Okay, so to correct, our y should be -1. So it should have been a -1, which would mean this +5. And when I subtract 5 from both sides, I'm going to get 3x equals -3, so x equals -1. Now let's check. Plugging -1 into the first equation for x and -1 for y in the first equation to get this. So that gives me -3 plus 5 equals 2. So that's right. Checks out. Get to in the second equation. Question mark here. Is this true? Well, yeah, you get -5 and -2 equals -7, and that checks out. Now you know you have the right solution. Then, of course, just to quickly review another way of checking is to sketch the graph. So sketch the graph. So first equation, the x-intercept is going to curve y equals 0. You're going to get x equals 2/3. So x equals 2/3 here. And I know that this is going to be a point in the graph of this function. And x equals 0, you get -5, y equals 2, so y is -2/5. Here's my first equation. Second equation, you're going to have y is 0, you get x equals 1.4. So let's see, 2/3 is here, 1.4 is going to be here. And then if x is 0, you're going to have 2y equals -7. Y is going to be -3.5. Now let's see, the -3.5 is probably going to be way down here. So when I sketch a line with the x and y intercepts in the second equation, I get this, and here's my point of interception. Now, if this is x equals terribly wrong. And you know what's wrong? X should have been negative 1.4. Bunch of mistakes. This line and everything. So yeah. Okay. Now we want x equals negative 1.4. Which is going to give us line or here. And then we sketch a line through the points. And we estimate this, because this would be the 0.11, negative 1. Yeah, sure. If this is 2/5 here and negative 2/5, then it's perfectly reasonable. That's negative 1. And if this is negative 1.4 here, it's perfectly reasonable that this is. So, quick sketch your graph, especially be careful about your signs and do it right. Okay, then can also help confirm your solution. Doesn't prove it. This proves your solution. This could be a quick way of confirming it if you draw a quick graph. Okay, so that's systems of equations and two unknowns. So we're going to shift gears now away from the equations of straight lines and so forth. And we're going to move into some properties of exponents, a couple of assignments. What's 2 cubed times 3 squared? Square. Well, what this means is 2 cubed times 3 squared multiplied by 2 cubed times 3 squared. And of course, we can change the order of multiplication. That means 2 cubed times 2 cubed. And then we multiply that by 3 squared times 3 squared. There are a lot of ways to write this out. Yeah. Well, 2 cubed is 2 times 2 times 2. You should easily be able to figure out that that's 8. And 3 squared is 3 times 3, that's 9. Now all you got to do is multiply 8 times 8 times 9 times 9. Well, that's 72 times 72. I'm just doing this in my head now. And that's going to be 5,044. Nothing in it, don't put it. Like that better. That might be right. There's still a question mark on it. You could use a calculator. Okay. Now, I'm gonna write this a little different now. 2Q times 2Q. The common error that people make. I think, well, since you're multiplying 2 cubed by 2 cubed, you should multiply the threes. Okay. So you'd say, well, okay, maybe that's 2 to the 3 times 3. Multiplied by 3 to the 2 times 2. Well, that's not, this isn't correct. I made a mistake. Okay. We multiply 2 to the 3 times 3 is 512. Let's see why. 3 times 3 is 9, so this would be 2 to the 9, which is 512. Okay. Now 3 to 2 times 2 equals 3 to the 4, which is 243. Yeah, 512 times 243. And without multiplying the numbers out exactly, just 500 times 200 is 100,000. So this number is greater than 100,000. And it's clearly not equal to 5184. Okay. So common error here is that you don't know what the rule for exponents is. Now maybe you do. And maybe you know it perfectly well and you just accidentally write it down carelessly. Okay. Here's the rule. What's 2 to the 3 times 2 to the 3rd times 2 to the 3rd means what? It means 2 times 2 times 2 times 2 times 2 times 2. Two to the 6th. It's not 2 to the 9th. Okay. And 2 to the 6th. 64. Not 512. Okay. Just illustrating that property of exponents. More about that. This board's too long. I'm gonna Right out for me. Two to the second times two to the fifth equals two to what power? One what? See if you can answer that question. It's not a trivial question. Camera off, so you don't have to watch between boards. Okay, hopefully. Picking up sound here. How about, two to the fifth, two to the second times two to the fifth equals what? You know, that was the question we asked. Okay. And people said it was two to the seventh because, it's fairly straightforward to imitate what we did here. Okay. Yeah, to what we did here. Where we added the extra. So people got that part right. When I asked for the reason, about half the class then wrote this. Okay. And that's exactly the reason. The reason is two to the second, you got a couple of twos, two to the fifth, you got five twos. So you have two plus five or seven twos, all multiplied together, that gives you two to the second. Okay, so the rule for twos would be two to the x times two to the y means, well, you got x up here, you got y up here, and they're all multiplied. So you got x plus y multiplied. And two to the x times two to the y is two to the x plus y. Or more generally, this doesn't apply just to twos. Okay, we could have any number here instead of two, and everything would be the same. I replaced all these twos by 743. I still have a true statement, although you wouldn't want to take the sum power of 743. Of course, with a calculator, it'd be easy. Okay, so generally any number, so I'll just say a is any number. A to the x times a to the y means you have x up here multiplied by y up here. So you're going to have a total of x plus y multiplied by a multiplied. Okay, now this rule is easily confused with the rule for power of the powers. Asking people to think through what would two to the third to the fourth mean, and what would our rule be? Now you might remember the rule, and that would be great because means that you remember it's important algebra. But we still want to explain it whether we remember it or not. Okay, again, hopefully we're correct. What's two to the third to the fourth? Two to what power? Think that one through. Okay, well, hopefully, if you're seeing this on video, you thought this through. First of all, two to the third is 2 times 2 times 2. And that's to the fourth power. That's a good first step. Everybody made that step. And then the next step is easy to see. Whether you saw it or not, you're going to understand. This just means take this thing and multiply it by itself 4 times. Okay. And that equals 2 to what power? Well, it's 2 to the 12th power, right? Because you got 3 groups of 4. And I can say that's equal to 2 to the I said 3 groups of 4. You got 4 groups of 3. 1, 2, 3, 4 groups, 3 in a group. I've got it right this time. It's 2 to the 4 times 3 because of this. And this should be very clear. So what's the rule? For a to the x to the y. Okay, I guess we're going. So what's a to the x times y? Well, just add 2 to the third to the fourth gives you 2 times 2 times 2, which is 2 to the third raised to the fourth power, which is 4 roots of 3 2's all multiplied together. And that's 4, 2 to the 4 times 3, which is then 2 to the 12. The 12 over there. A to the x plus y would equal a to the x times y. Okay, so we've got two rules that look a whole lot similar. And if you're careless, it's really easy to mix them up. Okay. Now, what do you think 2/3 to the fourth power would be? Okay, well, let's look at 2/3 to the fourth power then. Enough time to do this. Well, that's 2/3 times 2/3 times 2/3 times 3/3. Which is then, well, with fractions, you multiply the numerators and you multiply the denominators. So that's 2 times 2 times 2 times 2 divided by 3 times 3 times 3 times 3. And of course, we can write this then as 2 to the fourth over 3 to the fourth. Okay. And then we can calculate it. 2 to the fourth is 16. 3 to the fourth is 243. Thanks for writing that out. We're just wanting to look at the rules. So there we have. Okay. Now, what do we have? Two x cubed over 3y cubed, 2x squared over 3y cubed to the fourth power. What do you think you'd get there? Okay. I think we got the idea here. Let's get all the specifics. Here we go. Okay. 2x squared over 3y cubed to the fourth means this. We write this out 4 times as a multiplication. Okay, so now what's that equal? We can write the numerator as 2x squared times 2x squared times 2x squared times 2x squared. And the denominator as 3y cubed times 3y cubed times 3y cubed times 3y cubed. We can write down the numerator in a different order because the order of multiplication doesn't matter. We can write this as 2 times 2 times 2 times 2 times x squared times x squared times x squared times x squared divided by 3 times 3 times 3 times 3 times y cubed times y cubed times y cubed times y cubed. Now I could then multiply, I could then write all my x squared as x times x, x times x, x times x, x times x, right? And I could multiply my y, write my y cubes, 3y's and 3y's, 3y's and 3y's and count them up. But since we've already now got the rule for what happens when we do a power of power, I can write this more compactly as 2 to the 4th times x squared to the 4th divided by 3 to the 4th times y cubed to the 4th. Okay. In other words, I can take the 4th power of every factor of the numerator, every factor of the denominator. So I just kind of apply that 4th power to every factor I see here. Now, if I've got a plus or a minus in there, we can't do it. There's a plus or minus in there, it all goes to heck. Okay? In a way that maybe we'll see a little bit later. So I can say this. And we can see where this comes from over here. And if we ever forget the rule, we can reason it out. Okay? And we want to think why the rule works. Every time we do this, we want to think, okay, if I wanted to write this out, how would I write it out and show that it works? That way the rule sticks with you. And you can always test. I mean, you know, many times I was messing with my, you know, algebra really pretty well by the time I went up to college. I was very, very good at it. But I was still asking myself, okay, why am I adding these exponents? Why am I multiplying these exponents? And I had a quick answer. I just checked it out in, you know, a couple of seconds in my head. Okay, that's right. We add the exponents. Here's one. And I could do, I could run rings around most people of my age with the algebra. Okay, very good. Not bragging. There are people who are even a lot better, but the point is, even though I was easily 99th percentile, probably much better than that in my algebra, I still was asking myself, why does it? Okay, you want to do the same thing because I think if you don't, you're going to confuse yourself sometimes. It's very tempting and very easy to confuse. Okay, you want to be really careful. Okay, well, anyhow, you do this. Now you can then use this rule, show that this is 2 to the 4th times x to the 8th, and you just see, okay, but multiply 2 x's and then do that 4 times. I'm going to write out 8 x's. Yeah, that's going to be x to the 8th, right? And y cubed to the 4th, I'm going to have 4 sets of 3 y's. That's 12 y's. That's not 12 times y, that's 12. Well, if you think of how it's written down. So my best advice is always think of how these things are if they're written out. Another really good piece of advice, if you got something like 2x to the 583rd power to the 376th power, okay, you're obviously not even going to be able to visualize what that looks like, okay? Just say, okay, if it was x squared, yeah, if the x was squared, the y was cubed, and it's to the 4th power, what would I do? And am I going to do the same thing with 586 and 342. Okay, that makes sense. Okay. Well, so we're getting, we're pretty well into this. And of course, then we can do 2 to the 4th. So we might as well finish that. That's going to be 16 x to the 8th divided by 243 divided by 12. Well, it's going to be a little hard to read. I'm not going to try to read it. Okay. Well, now what would we get? We wanted to multiply let me make those numbers small. How much it is. Okay. No need to use. Five here. Write out what that is. Just go ahead and write it out in expanded form and let's see how it works out. Okay, so now I got pretty well there. We right. Yes. Okay, now there's a little confusion because people were a little confused about whether you had to have 5 2x's, right? Well, the 2x squared that we applied the 4th power to was in parentheses here, so the 4th power applied to, right? But the order of operations says first we do the exponent. The exponent is the 5th power of x. And then we do a multiplication, which is times 2. So we do x to the 5th, there it is, and then multiply that by 2. And similarly with the other. So it's pretty clear. This is what you all are writing down. Okay. So what we then have is I can write it like this. I can write this as 2 over 5 times you might not think of this, and I think you'll understand it. And it's okay, right now it's clear as wood. Okay. Through the 9. First place, the 2 and the 3 are multiplied in the numerator. The 5 and the 9 are part of what's multiplied in the numerator. So I can write them like so. And then I can multiply them out every time I want. Of course, the 3 divides into the 9 and all that stuff. Okay. Then I want to write my x. I've got 5 of them up here, 7 up and down here. Then I can write out my y terms. Okay, now if I multiply these fractions, I end up with 2 over 15. Kind of done with those. Over here, I can write this as I've got 5 x's in the numerator and 7 in the denominator. I can put the 5 in the numerator over 5 of the ones in the denominator. And then I can put the other 2 in the denominator in a different fraction. Okay? And then that's times this. So I can match up 3 of the y's in the denominator with the 3 in the numerator, right? And I get 2/15 times, well, I've got 5 x's in the numerator, 5 x's in the denominator. That just gives me 1. Now, some people say those cancel out. Well, yeah, I'm not sticky, but I don't like cancellation. All right, my x times x is x squared. And then y over 1 of is right as y. I'll make that right as y over 1. And that's 2/15 times 1 over x squared times y over 1, which comes out 2y over 15x squared. For that reason, open math is going to tell you that the y cubed down here cancels with 3 of the 4 y's that you have here. Okay, I like that word, but they're going to tell you that. And why does that happen? It's because I can group 3 of these y's down here with 3 of the y's up here. This is why you can take this and write this, that is just a y. Okay, also the x to the 5th will divide into x to the 7th, leaving you x squared, or 5 of these will cancel 5 of these, leaving you 2 in the denominator. That's what gets a little confusing. You need to practice some. But it's kind of problems you're going to see. Okay, I recommend that, especially for ones shorter, smaller exponents, you kind of write these out. The other thing is, I'm recommending that when you do your homework, you write it out coherently on a piece of paper. Don't just get the right answer in open math and think that you've learned it. Okay, you learn it much better if you write out what you're doing. And then if you do that, just have your notebook open to that while you take your quiz, and I'll come in and take a look at it. Just so I can pick up on things that you might need to hear. It's not required that you do that, but I think you would learn it much better and more quickly. Okay. Now, you seem to be doing okay, but we're to come in. Well, I'm gonna work out an opportunity for you to do some practice. Okay. Right now, get the test. Okay. Really, anytime this week is okay. But don't get behind in your homework. Okay, I guess this is pause.